NEC, Laboratories Europe, we try to build prototype-based models that are interpretable and also can reach a high performance at the same time. Because the problem that we see currently is that when you have a black box model, their performance is usually pretty good. And if you have a white box model, like a prototype-based model, the performance can't compete with the black box. But of course, the model is interpretable. So it seems to be like a trade-off. And we are trying to remove this trade-off or to lower this trade-off by rethinking the definition of prototype-based learning. So in general, we build on the generalized learning vector quantization algorithm that NEC invented. And we consider, for example, the definition of prototypes. So we try to make the definition of prototypes more powerful, which is, for example, about going away from prototypes being points to more complicated mathematical definitions as sets. And we also are considering how we can have a better class label assignment in prototype-based learning, or how we can build shallow neural networks with prototype-based learning methods so that these methods are really powerful in terms of accuracy, for example, but are still interpretable at the same time. In general, all applications that are considered to be of high risk in accordance with the upcoming EU AI Act. And these are, for example, life sciences, public safety, financial services, and also protection from cyber threat. In the last years, we have seen a growing interest in the application and in the development of prototype-based models. So the applications move from pure tabular data to the image domain, so computer vision, and also to natural language processing. So right now you can find models and studies where people have these methods applied to all these different domains. And this is great, but in general, they all face the same problem. So when they want to, for example, boost the performance of these models, they often then incorporate again black boxes, deep neural networks to have better features so that the performance of the models is improved. But the problem with this approach is that when you incorporate in this entire pipeline of your machine learning pipeline a black box model, then the entire model is a black box, basically. Because if one component can't be understood, the entire model can't be understood. And so I think we will see great improvements with respect to this issue. The other major field where I expect big improvements is in the evaluation of the interpretability. So right now in the XAI domain, there is no agreed standard on how do you evaluate the interpretability of a model, or how do you evaluate even explainability methods. And I also think that in the next years, the research community will come up with a unified approach that works in all the domains.
Orchestrating a brighter world. NEC.